Okay, guys, here I am sitting in the hospital getting my iron dripping into my arm. So I have 3 hours to kill. So I thought I would give the lesson that you would have gotten from me today, and you can check it on video. Okay? Alrighty, so a radical is anything with one of those symbols. Now remember, there can be a little number there. If it's got that, it's a radical. And this can be any other number. The y is the index, and the x is what we call the radicand. Now, the little y tells us the number of factors. So remember, when it's x, when there's no number there, I'm looking for 2 factors. So that's like the square root of 9 equals 3 times 3. 2 factors. If there's a little 3 there, I'm looking for 3 factors. So for 27, it would be 3 times 3 times 3. 3 factors. If it's a 4, I'm looking for 4 factors. 3 times 3 times 3 times 3. 4 of them. Okay? So an entire radical is an index and a radicand with nothing out in front. A mixed radical, and I'm going to change colors for this, has a number out in front. That number is called a coefficient. And it's just like if I had 2x, that is a coefficient, and that means 2 times x. This means z times that root. And it's all multiply. So how we simplify radicals is what we've been doing for the last couple of days. We take 72 and we break it down. I'm going to make a tree for the first one. 8 and 9, 2 and 4, 2 and 2, 3 and 3. And 70, so the square root of 72 is the same as the square root of 2 times 2 times 2 times 3 times 3. Now you'll notice, since I have no little number here, that means it's a 2. So I'm looking for groups. I'm looking for groups of 2. There's a group of 2. Now, over here, square root of 9, I take out a 3. So this 2 comes out here. There's a group of 2, so that comes out there. So I've got a 2 from that group. I've got a 3 from that group. And this lonely 2 has to stay under there. Now, what do you think these numbers do together when they go out in front? Well, they're coefficients, so they must multiply. So I get 6 root 2. Now, there's some shortcuts to doing this, and I'm going to show you some of those shortcuts as we go through. So let's start with this first one, 99. If I make a tree, that's 3 times 33, which is 3 times 11. So the root of 99 is 3 squared times 11. 3 times 3. There's a group of 2. Since I have no index, that must mean I'm looking for groups of 2. There's a group of 2, so out it comes. 3, and I left an 11 under there. All right, now I'm going to do this one the same way. 75, since it ends in 5, 5 and 15, 5 and 3. So root 75 equals the root of 5 squared times 3. You'll notice there's a group of 2, so out comes 5, and the 3 stays under there. Now I want you guys to notice something. 3 squared is 9. So this is the same as the square root of 9 times 11. The square root of 9 is 3, so I bring out a 3, and I get 3 root 11. This is 25. So this is the same as the square root of 25 times 3. Square root of 25 is 5, so out comes a 5, and I left in there a 3. Remember when I said that if you know your perfect squares, you can make your life easier. So let's look at 80. 80, we know is 4 times 20, right? And 4 times 20 is 4 times 5. So I got 4 times 4 times 5. What's the square root of 4? 2. What's the square root of 4? 2. 2's on the outside. 2 times 2 is 4. And what did I leave in there? 5. Look at this one. 300. We know that that's the same as 3 times 100. Why did I choose 100? Because 100 has a perfect square. What's the square root of 100? It's 10. So out comes 10. And I left under there a 3. See where I'm going with this. 63 is 9 times 7. Why did I choose 9? Because 9 has a square root of 3. So that's 3 root 7. Now, just to remind you, if you don't get this, you can always do 9 times 7, prime number, 3 times 3. There's your group of 2. 32, we know, is 16 times 2. 16 has a square root, it's 4. So it's 4 root 2. 363, that's a little harder because the number's big. So when it's a little harder, you can go 363, divide it by 3 and get 121. And I get to stop there, don't I? Because 121 is a perfect square. So really, this is the square root of 3 times 121. 121 is 11 root 3. Now, this is going the other way. Remember that when there's no number there, this is really that square root of 5, right? So if I had 2 2's, 1 2 out here, then under there I must have had 2 times 2 times 5. So I could take that out here, right? So this little 2 there, 2 squared, has to go back under there. So it's the square root of 5 times 2 squared, which is the square root of 5 times 4, which is the square root of 20. So in this one, there's no number there, so I'm going to write in the little 2 to remind myself. 7 squared. So this has to be 7 squared under there times 29, which is 49 times 29, which is, I go to my calculator because that's a big number, 49 times 29, 1,421. This one I put a little 2 there. So that's 4 times 6 squared, which is 4 times 36, which is 144. Now this one's tricky. There's a negative there. That negative is separate from the radical. So what this really is negative 5 root 12. So I put a little 2 there to remind myself, which means it's negative root 12 times 5 squared, which is negative root 12 times 25, which equals negative root 400. Okay, now let's mix it up a little. Look at this one for a second. What's different? That little 3 right there. What does that mean? That means instead of a group of 2, I need a group of 3. So I take 54 and I break it down. 9 and 6, 2 and 3, 3 and 3. So 54, cube root of 54 is really 1, 2, 3 3s, 3 cubed times 2. There's my group of 3, so out it comes 3 cubed root 2. This one, 144. I break down 144 to 12 and 12, to 3 and 4, to 2 and 2, to 3 and 4, to 2 and 2. And the root of 144, cube root of 144, is really 2 to the 4th times 3 squared. Is there a group of 3 there? Right there. So out comes a 2, and I left 1 2 under there, and I left 2 3s under there. So it's 2 cube root 18. 4th root of 128. So I got to take 128, and now I'm looking for a group of 4. So I break it down. I'm going to use the stairs method this time. So I can see it is 1, 2, 3, 4, 5, 6, 7 2s. So this is the 4th root of 2 to the 7th. How many groups of 4 can I get out of there? 1. What did that leave under there? 2 to the 3rd. 2 to the 3rd is 8. $162. Go ahead and do the stairs. 81, 3, which is 27, 3, which is 9, 3, and 3. There's my group of 4. So out comes the 3, and I left in there 1, 2. 108, I'm looking for a group of how much? A group of 3. 108 is 27 times 4. Why did I choose 27 there? Because I know that 27 has a cubed root. So the cube root of 27 times 4. What's the cube root of 27? Out it comes, and it's 3. So it's 3 cube root 4. Now back to this one, that's got no number there, so it's just a square root. So I can go 108, and I can break it down to 12 and 8. I lie, 12 and 9. I'm going to stop at 9, and 3 and 4. Why did I stop at 9 and 4? Because they're perfect squares. So I got 3 times 4 times 9. What's the square root of 4? Out comes a 2. What's the square root of 9? Out comes a 3. 2 times 3 is 6. Root 3. This is the same thing, except it's 3 cubed now. So that's the cubed root of 3 cubed times 4. 3 cubed is 27. Times 4 is the cube root of 108. This is 6 to the 4th. 6 to the 4th times 5. So that is 6 to the 4th. I can go to my calculator. 6 exponent 4, 1296 times 5, 6,480. This one is 5 cubed times 7, which is the cube root of 125 times 7, which is, brain fart, 125 times 7, 875. And then the rest of these are just practice. 105 is 5 and 21, 3 and 7. Any pairs? No. So this is already done. You can't make it simpler. 196, you know, is 14 because it's a perfect square. This one, 432, 216. And you can stop there because that's got a cube root. So cube root of 2 times 216. The cube root of 216, if you look on your chart, is 6. So it's 6 cube root 2. 3750. I would use 375 and 10. 2 and 5. 375 is going to be 5, and that's going to be 75. 75 is going to break down into 2 and 3 and 25. 25 is going to be 5 and 5. So this is the 4th root of 1, 2, 3, 4 5s, 5 to the 4th, times 2 times 3. There's a group of 4, so 5 comes out, and I leave in there 6. $384. That's going to be 192 and 2, which I'm going to break down again to 90. I lie. Yeah, 2 goes into 19 9 times, 91. I lie, 96. 6 and 2, and that's going to be 2 and 48. Oh, I'm going to run out of room, guys. Sorry. 384. 2 and 192. 2 and 96. 2 and 48. 2 and 24. 2 and 12. 2 and 6. 2 and 3. 1, 2, 3, 4, 5, 6, 7 2s. 2 to the 7th times 3. How many groups of 2 can I get out of there? 3 groups of 2. So that's going to be 2 times 2 times 2. And I left under there a 2 and a 3, which is 8 root 6. Then over here, remember that negative, it's by itself. So I do 180 and I break it down to 90, 9, and 10, 3 and 3, 2 and 5. So I got negative 2, 3 squared, times 2 squared times 5. Out comes a 3, out comes a 2. So it's going to be negative 12 root 5, because I got to leave a 5 in there. Now, no calculator here, so all you do is you convert them. That is the root of 5 squared times 2, which is root 50. That is the root of 4 squared times 3, which is root 48. That is the root of 3 squared times 6, which is root 54. That is the root of 2 squared times 7, which is root 28. And that is the root of 6 squared times 2, which is root 72. And then it becomes super easy to put it in order. What's the smallest one? Root 28, which was 2 root 7. That's the lowest. Then root 48, which was 4 root 3. Then root 50, which was 5 root 2. Then root 54, which was 3 root 6. Then 6 root 2. That's the order they go in. Come down to here and you do the same thing, but you got to keep your eye on him. That's the root of 6 squared times 5, which is the root of 180. This guy is the root of 2 squared times 13, which is root 52. This guy is the root of 3 squared times 4, which is root 36. And this guy, cube root of 10. You got to use your head to do that. That's an estimating thing, right? 2 cubed equals 8. 3 cubed equals 27. So the cube root of 10 is just a little bit more than 2. So the cube root of 10 is approximately 2. Well, the root of 36 is 6, the root of 52 is 7, and the root of 180 is almost 14, so you put it in order. Cube root 10 is the lowest, then 3 root 4, then 2 root 13, then 6 root 5. And that's it.